Today's lesson will be solving multi-step inequalities. And remember, this is something to keep in mind, 2 times that you will flip the inequality symbol. One is when you want to see the variable on the left. If you solve the inequality and the variable's on the right, you can flip the whole thing, including the symbol, to write the variable on the left. The other time is when you are multiplying or dividing by a negative number to solve it. So you might want to draw attention to those 2 points so that you have the inequality symbol in the correct way. Okay, in the first example, just watch and kind of listen and see what we're doing. And the second one, I'll let you work it out with me. Okay, so for this one we have to clear the parentheses first. So we're going to be doing the distributive property on both sides of the inequality. I'm keeping the symbol. And remember, when you have variables on both sides, you want to move the variable expression term to one side and the constant to the other. So I will be moving 4n to the left and subtracting it from the like term. And if I want to, I can go ahead and move, if you want to show your work this way, if you can keep it straight, the constant to the right in the same step. So we would have n, in this case, is greater than 34. Remember to graph them. And the graphs will be available and on your worksheet. And remember that the greater than and less than gets an open circle, and it would point to all the solutions greater than 34. So let's try one. This one's a little bit more difficult. So let's try this. Work this out with me. So we will be distributing the 5. We will be distributing the -2. And on the right-hand side, distributing another 5. So the simplified expression starts out with 5k plus 20. A -2 times k would be minus 2k. -2 times 6 minus 12. Bring in the symbol. 5 times k, 5 times 1, and bring down the minus 1. Before we start, we're going to want to combine some like terms on each side of the inequality. So remember how we combine our like terms. So we have constants and variable terms to be combined. So we can write that simplified version as 3k plus 8 will be less than or equal to, look what I did. I knew that didn't look right. That's okay. Remember when you're distributing and you're checking your work. So that could have easily been overlooked and an error made because 1 minus 1 is 0 and I wouldn't have had anything over there. So always be very careful when you're doing your work so that you can catch those. So we have our 5k, and then we have 5 minus 1, or a positive 4. Okay, moving the variable. I always like to move the variable to the left. It doesn't matter. Some people like to avoid negatives at all costs. You get the same answer either way. So since I like to move the variable to the left, I will subtract 5k from both sides. Okay, and then I'm going to go back in. I like to change colors just so you can see it. I'll subtract, since I moved the variable to the left, I need to move the constant to the right, which means I have to subtract 8 from both sides. Okay, so this is 0 and this is 0. I hope that's not too confusing for me to do both in kind of that one step. So 3 minus 5 is a -2k, still less than or equal to and in this case it's a -4. So my second step to solve this or undo the operation would be to divide by a -2 on both sides, and remember that's going to flip the symbol. Okay. If at this stage I decided to move the 3k, I would be subtracting 3k from both sides, and then I'd be subtracting 4 from both sides. So 8 minus 4 is a positive 4, right? The symbol would still be less than, and then 5 minus 3 is 2k, and in this case, since I'm dividing by a positive number, because I wanted to keep all of them positive, my answer is the same. You can see this, that the inequality symbol has the greater than side of it pointing to the variable, and it also has the greater than side of it pointing to the variable here. When we graph a greater than or equal to, remember it's a solid circle, so the graph, no matter whether you chose to keep it the variable part positive or whether you worked with the negatives, will be the same. Okay, in this example, we can see that the expression on the right, the 2x minus 15, is being divided by 3. So I'm going to show you how to go ahead and get rid of, we're going to undo the division in this case first, which is not what we normally do. But the reason is we want to get rid of that dividing by 3. So if we multiply both sides by 3, the one on the right will cancel out. We can simplify the expression as 3x is less than 2x minus 15. Subtract 2x from both sides and get x is less than a -15, and then you could go ahead and graph that, which would be an open circle at -15 and pointing to the left. Okay, and our final example for the day, we'll work with a decimal. So we'll follow the exact same steps. In this case, I'm going to go ahead and move the variable to the left. I'll move the constant to the right. So I am subtracting the 0.2 m from both sides. I am then also subtracting a 0.3, this decimal 0.3, to move this to the right. Okay. So 2 minus 2/10 will be 1 8/10 of m, less than or equal to 2.1 minus the 0.3 is 1.8. So since I'm dividing by the exact same thing on both sides, m is less than or equal to a positive 1. I could graph that, which on your homework you will be graphing. So it's going to be a closed circle, and it will point to the left. All right, some special cases. If you're solving a problem, we've done this with variables on both sides, and you get the same variable and you subtract it from both sides that you leave the variable, you look at the statement, is 4 greater than 6? Since this is not true, there's no solution in this case. So this isn't the same as the equations, right? But it's similar. So if 4 is not greater than 6, then your answer is that there is no solution. Okay, and in a special case number 2, if you're working it out and you distribute, combine your like terms, get your variables on the same side, and you look at the statement, and it is true, then it is all numbers. Because 9 is less than 31, it's true, then all numbers would make it true.